Okay, so 10.15 notes is representing functions as power series. Okay, again, just like you did on the other one at the top, right? FRQ. So between 10.14 and 10.15, every year there has been guaranteed at least one of these as your BC portion FRQ. Okay, notice that the table that is up here is the same table from 10.14. Okay, so memorize this same table. And so when doing a problem like this, especially on FRQ, there's two different types of problems they can ask you to find. And that is either ones like number 1 or ones like number 2. So that's either where they're asking you to find the derivative or they're asking you to find the integral. Okay, so let's look at the first one where it's asking you to find the derivative. So looking at this says f of x is equal to the summation of n equals 0 to infinity of x to the power of 5n over n factorial, then find f prime of x. So you should be looking at this part, okay, going back up for the series notations that you have memorized, and tell yourself this looks the most similar to e to the x. But because it has that extra 5 in the exponent, this is actually e to the 5x. Okay, so I'm just going to write that off to the side, e to the 5x. Okay, that's going to help me when I'm doing my series expansions. Okay, you cannot just say, okay, this is similar to e to the 5x, so that means the derivative must be 5e to the 5x. Okay, they're going to mark it wrong. Okay, even if they don't tell you to use a Maclaurin series, just by looking at this series notation, that should tell you what you're doing. Okay, because if they wanted you to find the derivative of e to the 5x, they would have just said find the derivative of e to the 5x. So the first thing I'm going to do is I'm going to write down my series expansion for e to the 5x. That means I'm using the series expansion for e to the x, and I'm just going to be having an additional 5 in the exponents. So f of x is equal to 1 plus x to the 5 plus x to the 10 power divided by 2 factorial plus x to the 15th power over 3 factorial, etc. Again, where am I finding this? It's because I have this memorized here. Okay, and so anywhere that I have an x with an exponent, I'm multiplying that exponent by 5. Okay, so that's why this is 5, 10, 15, etc. Okay, there's 2 different ways you can solve this, and either will be correct. So I'm going to show you method 1. And it kind of goes back to the last notes where we could show you with the expanded series and then with the series notation. So the first method is to look at the function that you've already expanded here and then take the derivative of it, which means you would take the derivative of every individual term. Okay, so the derivative of 1 is 0. We don't write that. The derivative of x to the 5th is 5x to the 4th. Okay, and we would continue. We don't worry about the denominator because 2 factorial and 3 factorial are just constants. Okay, so just leave them on the denominator. So this becomes plus 10x to the 9 over 2, and then plus 15x to the 14 over 6. Okay, remember 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. Okay, and then of course this continues. Okay. So that would be one way. Okay, you found the derivative. Another way would be using the series notation. Okay. So first what I'm going to do is I'm going to rewrite what we have here for the function. So f of x is equal to the summation of n equals 0 to infinity x to the 5n over n factorial. Okay, so if I was to take the derivative of this, okay, I'm just using the power rule. Okay, so I'm going to take this 5n that's on the exponent, bring it down, and subtract 1. The only difference that's going to happen is instead of saying n is equal to 0, I'm going to start at the first term, n is equal to 1. Okay, that's the only thing extra that you would have to know. Okay, and so this becomes 5n times x to the 5n minus 1, okay, over n factorial. Again, the denominator doesn't change because n is just a constant. Okay. And then one additional thing that I would do is I would simplify this, and how you would simplify this is remembering your properties of factorials. So if we have n over n factorial, okay, which we do here, that is the same as saying n over n times n minus 1 factorial. Okay, the reason we do this is because the n's cancel, and so we're just left with 1 over n minus 1 factorial. So really, if we were simplifying this, this would be the summation of n equals 1 to infinity of 5x to the power of 5n minus 1 over n minus 1 factorial. This is a correct answer, and this is a correct answer. Okay. These two right here are the same thing. One is just the expanded version. Okay. Which one is more exact, though? 1 or 2? 2. 2 is more exact because you're showing from the first term all the way to infinity, versus on number 1, you only showed the first 3 terms. Okay, you said that it continues on, but you didn't actually show all the terms like the series notation does. So this would be, again, one of those on an FRQ where either way would be accepted, but for the sake of safety, just to be safe, just show both. Okay? Unless they say only use the series expansion, or if they say only use the series notation, then you would choose just the one that corresponds. Okay, so that's one FRQ that you might see, and that's taking the derivative. The other one is going to be taking the integral. So number 2 says write the first 4 non-zero terms for the Maclaurin series that represents the integral of 0 to x sine of t to the 7th power dt. Okay, so the first thing you're going to do is you're going to look in this problem and you're going to figure out what function you already know the series expansion for, and that's going to be what? Sine. Good. Sine of x. So I am going to do sine of x is equal to, and again, this is something I have memorized, x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial all the way to negative 1 to the power of n times x to the power of 2n plus 1 all over 2n plus 1 factorial. Okay, and since I know sine of x, that means I can find sine of t to the 7 by plugging in t to the 7th power anywhere I see a x. So sine of t to the 7th, and when I plug this in, I'm going to go ahead and simplify the exponents as I plug it in. So this is going to become t to the 7th minus t to the 21 over 3 factorial plus t to the 35 over 5 factorial minus t to the 49 over 7 factorial plus all the way to negative 1 to the power of n, t to the 7th power to the power of 2n plus 1 all over 2n plus 1 factorial. So anywhere there was an x, I plugged in t to the 7th power. Okay, well, it wants me to do the integration of this. So if I integrate sine of t to the 7th power from 0 to x, that's the same as just integrating each individual term. But since in the problem it only wants the first 4, that means I only have to integrate the first 4. Okay, so I'm only going to integrate the first 4. When I integrate them, you're going to have some really large denominators. You can just leave the 3 factorial, 5 factorial there. Okay, and I'll show you what I mean. So if I integrate t to the 7th, this is t to the 8th over 8th. The next one is going to be minus t to the 22nd over 22 times 3 factorial. I'm just leaving it there. I'm not going to try to simplify because I'm not guaranteed a calculator on this question. Okay, so don't try to simplify. If you try to simplify and you simplify wrong, they're going to mark you wrong. Okay, and this is going to be plus t to the 36th power over 36 times 5 factorial minus t to the 50th power over 50 times 7 factorial. And then we're solving this from 0 to x. And so what's going to happen if I plug in 0? Good, it's all going to go to 0, right? If I plug in 0, every single term is 0. So really I'm just plugging in x, which means I'm swapping the t for x. And so I get x to the 8th power over 8 minus x to the 22nd over 22 times 3 factorial plus x to the 36th power over 36 times 5 factorial minus x to the 50th power divided by 50 times 7 factorial. This right here is my answer.